It's just after 7 a.m. on the 6th of August 1945. The Enola Gay, call sign Dimples82, receives a radio message. Cloud cover less than 3/10 at all altitudes. Advice: bomb primary. At 8:15, the Enola Gay releases its single payload. Moments later, Little Boy detonates 580 meters above the city of Hiroshima, killing 70,000 people nearly instantly. Whilst the necessity of dropping both atomic bombs has long been debated, there's almost no debate over the sheer destructive power of both devices. So, what's this got to do with global warming? Well, because of extra greenhouse gases in our atmosphere, mainly CO2, the Earth is absorbing more energy from the sun's rays than is being released back into space. In other words, the Earth is gaining energy in the form of heat. Little Boy released 15 kilotons of explosive power upon detonation. So, in regards to this energy, how many atomic bombs would it take to equal just the daily extra energy absorbed by the planet because of global warming? Take a guess, and I'll tell you in just a moment. The answer? 400,000 Hiroshima bombs worth of energy per day. That's about 4.6 every second. That is a lot of energy. But before we go on to calculations, how do we know this is the case? Where does this number actually come from? If the Earth is absorbing all this extra energy, then it has to go somewhere, right? So, by accurately measuring what is referred to as the Earth's heat reservoirs, then we should be able to get a good estimate for everything I've mentioned. So, this is exactly what scientists did a number of years ago, and they found most of this energy was being absorbed by the world's oceans, particularly the upper 200 meters. In fact, this number has been quoted a number of times, most notably during James Hansen's TED Talk back in 2012, and the numbers have only been going up since. So, we know that it's about 4.6 Hiroshima bombs every second, but how long would it take to equal humanity's most destructive device? Well, the largest bomb to ever be detonated was the Tsar bomber by the Soviet Union. This bomb had a blast of 50 megatons. That is more than 3,000 times more powerful than the Hiroshima bomb. The 26-ton hydrogen bomb was detonated on the 30th of October 1961. The resultant flash from the blast was seen from more than 1,000 kilometers away. The resultant mushroom cloud reached more than 5 times higher than the cruising altitude of a commercial jet, with the cloud being more than 100 kilometers across. A village more than 55 kilometers away was completely leveled. This was a weapon of last resort, designed to be so destructive that nobody ever would mess with the Soviet Union. However, if we go back to our numbers from earlier, at 4.6 bombs per second, it would only take us 720 seconds to reach the equivalent amount of energy being absorbed. That's only about 12 minutes. Yeah, that's not very long. So, what about a natural disaster? How long would it take us to absorb the equivalent energy of an extinction level event? For this, let's look at the KT impact, otherwise known as the asteroid that took out all the non-avian dinosaurs. About 65 million years ago, an asteroid 10 kilometers across smacked into the sea just off the Gulf of Mexico, punching a hole 20 kilometers deep. That's about double the deepest that mankind has ever been able to drill. The impact was so forceful and released so much energy that if all of it had gone straight into the atmosphere, then globally the air would have warmed by 40 degrees. enough to have cooked almost all of humanity if it happened today. Now, finding exact numbers for how much energy was released during this impact is understandably difficult, but I did find a few references that give at least a range of the energies that could have been. Links below. Alright, so let's take the extreme ends to try and get a range for the global warming equivalent time to equal the energy of the impact. At the lower bound, we have an impact of about 1.2 times 10 to the 23 joules, or about 1.8 times 10 to the 9 Hiroshima bombs. At 4.6 blasts per second, that's about 4 times 10 to the 8 seconds, or just 12.5 years. But the higher bound was significantly more. At the extreme end, we have 3.4 times 10 to the 24 joules, or 5.4 times 10 to the 10 bombs. Same rate, let's go, that'll give us 1.2 times 10 to the 10 seconds, or 369.4 years. Yeah, that's quite a range. Despite this range, most of the results that I found were actually reasonably close to each other and sat towards the lower end. In fact, if we go by the most common numbers, then we actually get about 6.6 times 10 to the 9 seconds, or about 20 years. Yeah, when dealing with an extinction level event, that's not very long. Because of man-made climate change, it looks like we're going to absorb the equivalent amount of energy to an extinction level event, and one of the most famous ones at that, within the next generation.